So today I'm looking at this thing. It's a Racal Dana counter. It's a 9918. There's also a sister model, which is, I think it's the 9921, I think it is. And it's got a channel C option over here, which is 3 GHz. In this configuration, it only goes up to 560 MHz apparently. This was basically given to me in exchange for some work I did for someone, and I've got no idea of condition. The guy sent it to me thinking it didn't work properly. There was something wrong with it. He wasn't sure. He just didn't really know. It wasn't really his thing. We'll have a look and see what's going on. It may even be perfectly fine, and I may not be a video in this. So look at it anyway. So you can see we've got voltage selection switches over here, which actually got a cover over them, which is nice. Stops you accidentally changing them. So it's set to WZ. WZ is 216 to 264 volts, which is perfect for my country. I haven't checked the fuse yet. I should definitely do that. And options 2, 4B and 09. So, or 02, 04B, 09, you want to call it that way. And there's like a little stick underneath it. There is something on it. UK and foreign patents applied for. Apparently that's what that sticker there says. Serial number 9944. I don't know. And it's got the adjustments here for the oscillator. These use a 5 MHz oscillator internally, which is stepped down to 1 MHz reference output, and also expects 1 MHz input if you're using external reference. Anyway, let's pull this fuse out and check that first in case something's horribly wrong there. Always pays to check that. Alright, check the fuse. Now talk about dodgy eyes. Here we go. I need my magnifier because I can't see the fuses anymore. I can't read them anymore. I have to use a magnifier. I used to be able to read them fine. 160 milliamps. That seems reasonable. So that's the correct one for the voltage as well, so that's great. Before I power this up though, I'm going to take the covers off, have a look inside just to make sure things are looking okay. Let's take the screws out. I've taken one out already. I've never worked on one of these counters before, like this particular version. I've done the 1991s and the 1992s and what's the other one? 1999 is it? 1998? Can't remember. I've worked in all of those, and I've done videos about those, repairing them and things like that. Different repairs. Okay, how do I get this apart? The bottom one's bent. Let's cover this. Let's see the bottom. It's all bent like that. Don't know if it's supposed to be like flimsy. So I'm not quite sure why the top one's not coming out. I guess I have to slide it one way and then lift it out. Something. It might be something as simple as that. Let's get a small spudger. Ah, there we go. It's just stuck. Big empty space here. Obviously that's for the C option. Channel C. Right, there's the inside. So obviously this is all for that channel C option, which, I don't know, there's quite a lot of space for that. And the rest of it looks relatively simple. Lots of tantalum capacitors. Yeah. Okay, let's have a close look. Tested in 1986. Okay, there's a chip there 85, so it could be initial testing when it's first made. Could be when it's made is 1986. Got these flat flex ribbons. Don't like these are really fragile. If you have to move things around, they tend to break. Obviously the back of the LED modules there. So the module over there, whether that is. Okay. Frequency standard 5 MHz, like I said before. So I'm guessing as it's got a coarse and fine, this is an ovenized one. That's probably what one of those options are on the back. You should actually look up the manual what the options are. So we've got some Phillips caps over here. And we've got another one down there. So those 3 caps are me doing. Looking for any reefers. I can't see reefers. Can't see any reefers, which is good. But it does obviously have one of those original filters in there still, which could also blow up. I'm not going to bother with that. Let's take the bottom cover off and see what we can see from the other side. So there's the bottom side. Not much to see. Obviously, you know, expected, hand laid out kind of PCB. Wiggly traces everywhere. But easy access to these capacitors down here. Although these capacitors aren't actually attached to the board in that same way. They are mounted to the chassis and they're wired through to the traces on the bottom. They're wired through the board like this. What a weird way of doing it. It's almost like they designed it wrong and didn't correct it. I think I should replace these before I do anything else, because the last thing I want to do is have this thing putting a bottle of then we need to know if it's working or not, eh? It can be hard to judge, like when you've got these ones that got these plastic caps on. They can, they appear to be bulged from the plastic cap. Anyway, so yeah, what we'll do is we'll power it up first, see if it seems to work, but I just want to see what it's doing right now. Then we'll fix the caps, replace these caps. There's only 3 caps to do, so we'll replace all 3 of them. And then we'll see if anything's changed, if it wasn't working properly the first time. And then hopefully we'll get somewhere with that. Cable plugged in, haven't turned the power on yet. Switches are where I want them to be. I've got a BNC cable ready in case I want to inject a signal. Power on. Drawing no power right now, which is good. That means the filters aren't blown up. Nothing happening over here. Just turn this on. So that's how small his digits are. Small profile. Anyway. Okay, you've got lighting, you've got gating, 24 watts. On the surface it appears to be working. Check. Says 1 megahertz. So the check is working. Okay. Let's inject a signal on channel A, which is what we're set to. I've got it set to 1 megahertz as well. That is reading. Okay. Let's do channel B. It might actually be working. Channel B. That is not working correctly. Let me increase the amplitude going in case it's a level thing. IF level, it's double the amplitude going in. That did not fix it. Okay, channel B is not working. And that's just 10 millivolts there, so that should be fine. So 10 millivolts minimum. I'm doing 200 millivolts, so that should be plenty for that. So channel A works, which means we know that the reference is working correctly, the counter is basically working correctly. It's obviously got a scaling circuit which scales this one down to this one, but it could be because of the power supply being very noisy. It's possible it's just putting out a lot of ripple and it's upsetting stuff. Digital circuitry does not like ripple. Well, actually, that's the point. It's only 40 megahertz reference there. Actually, it's a really good point. That's a really good point. I was only injecting 1 megahertz. Let's do 50 megahertz. So try 450. Could definitely do. Let's do 400. It's 400 megahertz. Yep. 500. Just to speed this up a little bit. So that's not looking right, is it? Let's do 560. Levels, let's go back down to 100 millivolts. Yeah, level's not really helping that. Normally level would change and improve the reading. Let's go 500 millivolts. Yeah, changing levels isn't helping it. Well, okay, I've also got the polarities to sort out as well. I'm not going to test them, I'm just going to take the bloody things out. 16 volt. It's definitely a weird way of doing it. Very weird way of doing it. Good old Schaffner filter. There'd be reefers in there. I'm not changing it. Very strange setup. I'll take them out, then I'll figure out polarities, so when I put the other ones in it should be right, but then it does appear to be a marking there. So there's a positive there, there's a positive here for each capacitor. So they're marked on the board, that's good. Let's get these things desoldered. 310 degrees, here we go, because it's got like a post here. And it looks like they're soldered into a post. I may need to put some fresh solder on. Oh, there we go. Let's put some fresh solder on to make it easier. Just to transfer the heat a bit easier. Okay, so the big one's out. Very weird setup. Very weird setup. Actually, they're left out. Then we've got the other blue one just down there. This axial. 470 microfarad. Constant voltage. We'll take that one out as well. Taking the top one out first. There you go. Now pull the bottom one out. Again. There we go. Is it warm enough yet? No, not quite. Still not quite warm enough. Don't do it too cold, otherwise it will freeze off inside the tube and block it. Alright. I'll make it easy to get the next one in. Right, where's your tester? Using the capacitor tester. 470 microfarad, 40 volts. Okay. So I've got my LC102 set up here. Let's test these capacitors and see what we're actually getting out of them. So this is one here is the 470 microfarad 40 volt. A small one. So the ESR first. I've already discharged the capacitors, make sure they're dead. That's actually measuring really well. Dielectric absorption. Good. Leakage. Good. Is this capacitor going to surprise me? Value 530. This capacitor is still good. Now this is actually really surprising because my experience with these Philips caps from this era, they're almost always bad. So I'm actually really surprised this one still measures okay. I'm really surprised. I'm tempted to put that one back in. This isn't something I normally do, but I'm tempted to because these axial caps are expensive. I do have some here. I do have new ones. What's that one there? 25 volt, or probably the high voltage in that one. But I do have some here I could use. But like I said, they're expensive. So I'm tempted to put that one back in. That's 25 volts, 2200 microfarad, and this one here is 16 volt. Let's pull the label off so I can see what it is. 4700. Okay. Let's take this one first. Okay. Here's that. Error. This is not detecting it. Is it completely open, or am I just got a bad connection? Let's try again. Adjust the connections. Okay, there we go. No bad connection. ESR look good. Strangely. Absorption's good. Leakage is good. And very good. Well, this says this part's good. 16 volt. But you know, I'm just amazed that that one tested okay. Right, ESR 07, bad connections again. It's probably trying to clip onto solder joints. ESR's good. It'd be funny if they actually test okay, wouldn't it? Good. Good. And good value. Well, okay. That's kind of surprising. Well, I'm going to do what I wouldn't normally do, which is to just put these capacitors back in again. I'd normally never do that. What's my tweezers? They test perfectly fine on a Sencore. And although they felt like they were bulged, I think it's just the design of the top. Where they've got a raised rib across the top rather than a pressed rib, like a cross across them. So I think they might actually still be alright. But this isn't something I normally do. Normally I will just replace them. If I've taken a cap out, I'll just put a new one in. But I'm not going to be keeping this thing, so I don't want to put any money into it. No, this isn't something I'm going to be keeping hold of. And so the caps test perfectly fine on the sink core. And I trust the sink core to say yes or no. And it does quite comprehensive testing, as you saw. As it said, yeah, they're good. I'm going to do what I wouldn't normally do and put them back in again. Like I said, Philips caps in the past have given me trouble, so I'm kind of mindful of that as well. I mean, any brand cap can give you trouble. Just, you know, when you get to this sort of age, I've seen the Philips ones be particularly problematic, so I'm very mindful of that. Putting them back in really does feel like sacrilege to me. Still got to put that one in yet. Right, solder this cap back in. Now I've got the thing back in place. Come on. Okay. Solder's too long. Deflecting off. Right, here we go. Got rubber mounts on here, which is interesting. Not sure there's... Yeah, it's still kind of intact. So obviously insulation from the ovenized oscillator here. Although the whole thing's an aluminium frame, so I'm not sure there's much benefit to that. So I put those capacitors back in again, even though it's not something I normally do. Normally I would just replace them. I wouldn't be messing around putting old caps back in, but they tested perfectly fine in the sink core. No signs of leakage or anything like that. They look fine, and I'm not going to be keeping this unit. If I was keeping it, then I want to make sure it's going to last another 20 years, so I'll just put new caps in. But who knows? I mean, I've got no use for this thing. I'm just going to be flicking it back on again. So these caps seem perfectly fine, so I'll put them back in. I'm not 100% sure. I trust them because of the issue we had with that channel being a bit weird. That channel B, that high frequency, not reading very well. It could still be a separate fault. I want to check for ripple on these capacitors here and to see if we're getting anything excessive. I mean, it is normal to see some ripple there. I just want to see if we're getting anything horrendous. I've got my scope set up now, which I'm going to change to in a second and show you the scope. So probe is there ready to go. I'm just going to probe on those three caps and just see what we get. Powered up. Let's measure these caps. So let's try this one first. It's the positive of the smaller of the big caps. Mind you, my trigger point's in the wrong place. Let's get a mouse. Hold on. Let's eject the mouse thing if I can see what I'm doing. Okay, we've got a little bit there. Just a little bit of noise. It's probably just from my LED lighting. Yeah, there's like nothing on that. Positive that one. Negative that one. To be sure. Look at that. So on the negative of that capacitor, we've got this ripple. But that looks completely normal. You know, 660 millivolts or so. But that's a completely normal ripple, like, yeah, rectified voltage. That's looking fine. It's a little bit on the higher side, but negative the other cap and positive the other cap. That's looking a bit more significant. Yeah, look at that. 1.8 volts. 1.8 volts peak to peak. That's the bigger of those two caps. That's the 4700. That doesn't look particularly great. I would expect to see that better than that. So I'm just going to put a 1000 microfarad across that and just see if it changes as well very much. As this is a much smaller value, like this cap here, it's much smaller, shouldn't have a big effect on it if this capacitor is working okay. But if this capacitor isn't working okay, then this will have a big effect. So let's stick this on there and on here. It did drop slightly. It dropped to like 300 millivolts. Not sure. That didn't convince me. Let's go 3300. Here we go. That's the 1.1 volts. Zoom in 3300 across there. It's still quite big. I'm unsure what to make of this because that ripple looks excessive to me, but putting a big cap across it hasn't really reduced it much. Yeah, maybe high current somewhere is certainly a possibility. Could be high current. Right, so I've got the thermal camera out, just checking for anything getting excessively hot, but unfortunately there's quite a few things getting quite hot. Interestingly, the power switch is one of those things. That's the power switch. Why is the power switch 40 degrees? Or is it? Actually, no, it's not. No, it's not. It's a circuit board right there. $42. Okay. Let's keep looking. It's not super hot. Up here, we've got something here which is 58 degrees. It's a chip. The main thing I'm looking for here is bad tantalums, because that's what I'm expecting to find as bad tantalum. And that being really hot over there is quite surprising. Got some transistors there, a little bit warm, 60 odd degrees, not too bad. There's a transistor there, which is okay. I'm not seeing anything like jumping out saying, hey, I'm 100 degrees and I'm completely blown up, which is kind of what I'd be expecting to see. That top board there, it's got more tantalums on it, not even featuring. That's a resistor which is getting hot up there, so that's not that unsurprising. I'm not actually seeing anything here which is like standing out as being particularly bad. That's the regulator, so that's alright. Yeah, the only thing I've got which is a bit interesting is that front panel there, which is a surprising amount of heat coming through the circuit board. That may be worth investigating. It's probably a driver chip for the actual LEDs though, so it could be getting hot because of the driving LEDs. Shit the back of the board, in case we see anything on the back. No, it all looks like the front really. Hot spots are where they were in the front, so yeah, I'm not really seeing anything abnormal. Mystery deepens. Just notice how close together these regulator legs are, just here. Now, I'm not sure if they're actually touching it. This is not currently powered up. I can't get the probe in between them. It's not slipping between. Now, I'm wondering if maybe I nudged it when I was moving these capacitors around, but that is actually fairly stiff, so nudging it isn't a thing. If I move it back like that, does that change anything? Let's check the voltage across all these regulators and see what we're getting. So the left pin of this one over here, getting nothing. Middle pin, minus 10.4. Right pin, minus 5. That's looking good. So over here, left pin, 8.6. Middle pin, nothing. Right pin, 5 volts. That's looking alright. So over here, 8.6, middle pin, nothing, right pin, 5 volts. Then over here we've got a 24 watt regulator, which is IC34, which is a bit harder to get under the pins. So let's check the left pin. 29 volts, that's a decent overhead. And the right pin I think is going to there. 23.9. Yeah, I mean those voltages are all looking fine. So that's looking alright at least. So now I've actually separated those two legs. Let's see if the ripple's still the same. So I just tested ripple on these regulators and the outputs. They're all looking perfectly fine. Nothing coming out the upside. Nothing noticeable. I mean, I've got the trigger set to like 300 millivolts or something like that. It's not really showing up, so regular output's fine. And the ripple on the inputs to regulators hasn't changed. So we've got 630 millivolts, or sorry, 650 millivolts across that capacitor there, 650 on that capacitor, and that one there has got the 1.7 volts ripple. But the regulators are taking it out. They don't care. So it's a non-issue. So it's just the count is dropping. So it's just consistently dropping down. It was over 460 before. Well, it was actually 480 something before, wasn't it? But it's dropping, dropping, dropping. That could be a clue. If something is drifting off like that, although nothing was particularly hot, maybe something is getting hot enough to upset the counting. Free spray. Let's see if anything changes when I spray some stuff. Nothing there. Oh, something changed then. See that? Okay. Be close there. That chip right there. There we go. Look at that. It's counting correctly now. Just have to keep spraying it. Now, could that just be a bad solder joint? Because, yeah, it could be. Thermal solder joint issue. Look at that, it's rock solid now. It's wrong, but it's rock solid. So, it's in this area here is where I sprayed. So, I tried up here first in this resistor, because that resistor there was measuring quite hot. So, I tried that first, that didn't change anything. Then I tried this chip, that didn't seem to change anything. I tried that one, didn't seem to change anything. And I think I did this one, and then it changed. Or then I looked up and it changed. So it was in this area here somewhere. And I sprayed in this area in general, and now it's going off again. Great, we can check that again. We can check it in some more detail. So I think we just need to use this thing only in a cold environment. See the fact it's dropping down now. So if I stick my finger on this chip, no. On that trimmer, nope. There's an array here. Oh yeah, look at that, moving that array. Ah, there's a thin film array on here, or some kind of device, and that is not looking like it's doing very well. It seems a bit, yeah. Moving this array around is changing that reading. Yeah, if I push down it changes, lift it up a little bit it changes. Pushing it changes it. Pushing somewhere else, not so much. So it's like this thin film thing here. Yeah, I think this thing here is the issue. Because I'm touching that and moving it around, and it's changing by quite a bit. So it could just be a bad solder joint. Let's just spray just that bit and see if it changes. Yep, see, it's changed. Yep. But could this be solder joints? If I spray the solder joints, bear in mind I've moved it around now. There we go. Yeah, I think I should resolder that chip and see what happens. So I was looking at solder joints in that IC there, and all this area looks absolutely beautiful. It's all nice and shiny. There's nothing there looking even slightly dodgy. Yeah, I can't see anything which stands out as being bad. I'm going to resolder it anyway, but that's not looking very promising. Well, let's resolder it, even though it looks fine. Let's resolder it anyway, you never know. It's just here. Right, let's try it again. Although now it's warm, I don't know, it might be worse if it's warm now. Well, plug that back in again and see what happens. Don't forget it's going to be warm for me soldering it. I'm just kind of wanting to see if it was going to drift around or not. I would have thought warmth would have made it worse if it's being improved by cold. It is drifting around, it's definitely not stable. If it is that module, this is likely the end of the device, because that would be probably impossible to get one. Yes, it's drifting. Yeah, look at that. Off it goes. Now, we're not 100% sure it is that device, but it's quite likely based on how it's behaving. I'm going to do some more spraying just in case it isn't exactly that. You never know. Could be something near it. There's a device right there. Let's just spray that. No. It's going to do near it on the board. Look at that. Okay. So that wasn't actually on the device. That was near it. Okay. Things are looking more promising. Things are looking more promising. Let's get some hot air here. Let's try and accelerate this process a little bit instead of waiting for it to cool down. Or warm up again. Let's get some hot air. Oh, she's got a big nozzle. Warm it up. Instantly gone. Look at that. Wow, that was fast. Okay, let's spray that chip. Not that chip. Capacitor. That capacitor right there. Instantly came back. Right there. Okay. Wow, that's really effective. Okay. There's a resistor right here. No. No. Resistors I'd check first because, yeah, it's right on that resistor, but it didn't completely cure it, it's near it. There's a diode right there. It's amazing how quick that changes. So, diode right there. Instantly. Okay, it looks like it's that diode, or something really close to that diode. I'll show you what I'm talking about. This is where I've been spraying, and when I sprayed on that capacitor, it instantly came right. So I tried each of these resistors, that didn't do it. I tried that resistor, didn't do it. As soon as I spray on this diode, it instantly comes back. So it could be a bad solder joint on this diode, but it's more likely that diode there's bad. So it looks like that's D17. I think that's 17. So I'll be looking at that. And if we're lucky, something like a 1N60 or something like that. Not sure if it is, but it could be. So what I'm going to do right now is just get my soldering iron and touch that diode with it. And if I touch that diode, nothing else, and that goes completely crazy, we know it's definitely a diode. Although having the ambient heating from the iron might affect it as well. Yep, diode. I'm pretty sure it's diode. So I'm just going to narrow this down some more. I'm 95% sure it's that diode, but not 100% sure. So there's a capacitor right next to it. So I'm just going to try heating that capacitor. No reaction. I've got the iron set to 100 degrees now, so it's much less sensitive for the circuitry around it. Let's touch the diode body again. Instantly changed. There's a resistor right behind that diode. No, that didn't change it. There's a device here, active device. No. Tantalum. No. Resistor right above the diode. That did make an effect, but not the same effect as touching the diode itself. Yeah. Heating up the resistor directly above that diode is affecting it. But doing the diode itself is having the greatest effect. I'm pretty sure it's a diode. I'm just removing that diode now. Desoldered it, so I've left it out. Then we'll try a 1N4148 and see if that works. It may or may not. Right, solder this thing back in again. Or rather solder it in. Not exactly back in, it's the first time it's been in there. Then we'll try it again. And see if it solved the problem or not. We'll see. So I just turned it on and straight away we're looking good, which is a good sign. Let's try heating the circuit up with the hot air again, see if it goes wacky. Nothing. And before it was instant when it played up. So that's actually looking like it's probably fixed. Let's leave this on for a while and see if it actually behaves or not. Well, I'm going to panel beat this thing before I put it back on. I'm just taking the feet off it because it's all warped and bent. Now this is going to be noisy, but I want to flatten this back out again before I refit it. I don't think I'll show you because it is going to be noisy. But you can imagine what hitting up the hammer sounds like, don't you? It'd be a bit like that, only noisier. Right, let's do a cold start on this thing and we'll see what current we get. I'm hoping that we can see the oven working, and so it'll be higher current when it first turns on, and then after a while the oven will turn off and you'll see the current draw drop. That's what I'm hoping to see. If we don't see a current reduction, then there could be an issue with the oven still. Don't forget the frequency is off, but it's not off by a huge amount. If it was off by a kilohertz or so, then I'd be thinking, okay, we've got a problem there with the oven that's not this way off, but it's only off by a small amount, so I think that's purely an adjustment issue. It could be someone's already adjusted it even though the oven's dead. That's also possible. I've come across that before. So anyway, we'll try and see what happens. So right now we're getting 24 watts. That's what we saw at the very beginning when we first powered it up. So again, 24 watts, and before I turned it off we were seeing about 19 watts. So that frequency there I expect to see shifting and then stabilise. So as the oven warms up, that should get closer and then the current will drop when it stabilises. So that's what I'm expecting to see. And if it does that, then the oven's working correctly. I don't think I've recorded the whole process. Maybe it will. Looks like it's getting close. Oh, mind you, I've still got that much to go yet. I'm still doing 500 megahertz. I'll come back once it's had a chance to stabilise. It could take a little while. So looking at this now, the wattage has started dropping. This frequency was going up, and now it's coming back down again, just very slowly. So I think it's the point now where the oven is starting to control itself. It's just got that PID control effectively, I suppose. Probably not complicated, but you know, it's a switching system. And so now it's reached that point, and now it's cooling down again now a little bit because it's reached the temperature it's expecting. And then it will come to a point where it will turn back on again, and this frequency will start going up again. And you might see an extra watt or so there. It won't turn on fully, I expect. I think it'll just turn on slightly, and we'll just try and maintain that set temperature. So it should stabilise. I'm not quite sure how well it will stabilise. Oven eyes aren't perfect, but they're not bad. I'm not sure how precise this will end up sitting at when it actually does settle down, but yeah. So it does look like it's actually being controlled properly. The watch is dropped. This came up in frequency, and now it's dropping back down again. Now the heater's turned off. Everything's working exactly how I expect it to. So I've shifted this over to a 10-second time base now, or gate time, and so you can see this is stabilising quite well now. So that's kilohertz, that's hertz, that's 100 millihertz. So we're only changing the last couple of digits very slowly and very slightly. It's stabilised quite well now. It's probably sort of 20 minutes or so now, maybe just over that. And yeah, see, let's change by one count. So that's stabilised quite well. So it looks like it's behaving exactly the way it should be. Now I'm currently warming up my Rubidium Standard, just here, warming this thing up. Once that's warmed up, I'll connect this up to it, and we'll check it against that as a 10 megahertz reference. And then we'll adjust the OCXO to suit the Rubidium, so this should be as accurate as I can get it. I do actually have a GPS DO, but I don't have that set up because, well, in this room here I don't get satellite signal, so you don't really get GPS signal in here. I have tried, it just didn't work very well. So I'll just use Rubidium for this sort of thing because it's fine, it's good enough. This is run out of digits anyway. This Rubidium's going to go far beyond what this can do. It'll be fine. So I hooked up the Rubidium, and this is what we're getting on that long time base and that long gate time, 10 seconds. Yeah. So let's just this is still you need it to stabilise. It hasn't been on for that long, 5 minutes maybe. So it's still not perfect. It's still going to be settling a little bit. Let's just go to a short gate time and make it easy to adjust, and we'll trim it on the back and we'll try and get this thing adjusted. So I was just trying to adjust the course adjustment, and I can only turn it down. I could actually increase the frequency, which is a bad sign. It was already fully maxed out when I started. I'm going to try the same thing with the fine adjustment and see if that does anything. If I can get back in the screwdriver slot, which I've just lost. Turning it is not doing much at all. It might have an issue with the oscillator. May not be fixed yet. Yeah, it's doing the fine. Fine's all the way in. Let's go longer gate time and we'll see what we get from that. It's going to take a minute. Well, 20 seconds to get a proper gate to count. 641, let's wait till the next count. Then I'll turn it and see what we get. Okay, 595, let's wind it out. That's all the way out. 585. So yeah, that's not adjusting. So basically, the fine and the course are fully wound in. So that's not good, because that means it can't actually be tuned to the correct frequency. Which means there's an issue with the OCXO. So that's on 960 now. Let's undo the course again. Go all the way out of the course one. That's out all the way on the course. Let's see what we get. Yeah, see that adjustment range is quite small, as it should be, and we're nowhere near where we should be on the frequency. So there is a problem. Yes, definitely a problem. And that's all the way back in again. Damn, I've got to take it back apart. So let's try the A input, just in case there's something weird thing with the B input. A input has also got the same issue, no difference. So that verifies that the reference has got a problem. So this has also got an issue. I'm going to take the thing out and then try and strip it down and have a look at it. So I'll make some notes about it first. We've got 3 wires going to the back here. White and red to that pin just there. Then we've got a black and white going to the first pin there. And this one here appears to just be a white wire. Can't see any stripes on it. So that's all that's there. I'm guessing the ground is going through the casing. So we'll unscrew it from there. It's got 2 screws there. We'll unmount it. Looks like we've got screws on the sides to take this out of the housing. And then we'll see what we get. If wires fall off, wires fall off. So I've unmounted it, and as expected that came out. I actually got a temptation here to remove the wiring from the main board, because the 3 wires just come down here. So you've got the red at the bottom, black in the middle, and the plain white at the top. So the 3 bottom connections there. So I think I should just take the wires off the board down here, then I can just work on this separately from the main unit. Well, module is out. Let's open up and see what we're dealing with inside. I've prepared OCXOs before. It's not the first time I've been inside one. Did one on, actually I've done 2 I think. I've done 2. Did one on an old Marconi unit, a modulation meter thing. I did a video on that many years ago when I first started my YouTube. I actually did it partly as well. I did some videos for Simon Spears because he had one of those same units. And I was trying to get some reference video for him so he could help repair his one. And then I think I did it on my 2022D as well. I think that one there was also broken, but that was before I started doing YouTube. Yeah, I've got no video on that one. But that's before I started doing videos. Predates that stuff. 15 years ago. It's foam, as expected. It's foam. Hopefully it doesn't turn to dust when I pull it out. Because that can happen, because it's very old. Let's just push it out. I want to be careful not to damage the foam. Because I want to put it back. Let's open this casing up. Actually, before I do that, let's see, it is very dusty here. This foam is disintegrating a little bit. Can I get this one out completely? I think it's kind of embedded. There we go. So you got an op amp there, another op amp there. There's a trimmer here. Trimmer. It was accessible from the side. And there's those 2 adjustments there. I don't know which way round it was. I think that's the fine, that's the coarse. I think that's the fine, that's the coarse there. Let's take this cover off. Let's have a look inside there. I don't know if this is actually covered in the service manual. I wonder if it is. I doubt it will be. It's got a nut in the bottom. Great. The bolts, not screws. Alright, and that's what's inside. Crystal, 1985 date. Got some capacitors in there and some transistors. Obviously that's the heating element and stuff down the bottom there too. That's all the heating circuitry, so it's encased. So, right, well I'm wondering if so everyone can see how these trimmers are set up. In fact, if you look at these, this one here looks different to this one. See that screw there? Now that's right, this one here must have the fine one, because when I was doing this I actually wound the fine one back out again a little bit. So that's the one screwed over first. So this one here's the fine adjustment. I thought I'd wind it back out a little bit just to put it more towards the midpoint. Let's try and put it more towards the midpoint. We'll try and adjust it for that. But yeah, I don't know. Anyway, I can't get the thing back in the slot again. This slot's awful. And this one here is the coarse one, which is turned all the way down. So we'll pull this back out a little bit. No, that much. Try powering this on the bench. The red wire here is 5 volts. The black one, or the black stripe, is negative, 0 volts. And the plain white wire is the output. So I've got the white wire and negative hooked up to my Racal Dana 1992 counter up there, so I can monitor the output. Obviously this isn't enclosed properly, it's going to not really stabilise very well, but I just want to see if I can get it close, and I want to see if this, I suppose I could measure the resistance across it and find out where it's sitting in the natural range. So centre pin to that side is 616 ohms, and centre pin to this side is 312 ohms. So I know roughly where it is. It's like 2/3 of the way adjusted. So I've just powered this up. It's drawing 600 milliamps for the oven, so it's not too bad. Generating 5 megahertz, and we'll see what happens once it warms up a little bit. It could take a while because it's not enclosed, and I can't really adjust it until it is stabilised. So yeah. So there's my 1992 hooked up to the output, and so you can see what frequency that is currently generating. So yeah, we'll see what it settles down to once it warms up. So it's all stabilised now, even though it's not in ideal conditions. It's sitting at 5.0000212 megahertz, and current is 340 milliamps right now. Now when I take this cover off, it's likely to upset it. I don't know how much of an effect it's going to have. So I'm going to try playing with this a little bit and just see if I can drag the capacitance down, because it's definitely heating, it's hot, and it's doing what it's supposed to do. Obviously I've got the insulation off now, which is probably not good for it, but it's stabilised. So what I'm going to do is see if I can do something with trying to adjust the frequency here artificially. I want to see if I can trim it with capacitance. So I'm going to cover it back up again for now, so the heater's not working too hard. But I do want to trim it in some way. Let's just do this to try and protect it a little bit. Don't want the heater burning out or anything, that'd be really bad. Right now it's not unsalvageable, it can still be salvaged, so I need to get it modified to make it work. But I can't see any reason for it not to be correct right now. So I've been trying different capacitors across one of these trimmers here. I'm up to 270 picofarad. I'm going to shove this in, and then I'm going to see if I can adjust it down to frequency. It's getting really close, it's only like 3 Hz out with this one. So I'm going to see if this will be enough whilst not holding the capacitor, and also trying to adjust the trimmers to get it on frequency if I can. I mean, that's what I'm hoping for, is adjusting it to be on frequency. Get these wires out of the way, getting tangled up. Kind of want to bend this around so it's not going to touch anything. Try to do as quick as I can, because it obviously needs to stabilise in temperature again, which will take a while. Power back on. Cover it back up again. Give it a chance to warm up, then we'll see what happens. See if I'm going in the right direction with this or not. Right, that's where the thing's stabilised to, on the bench in pieces. Let's just try adjusting it and see if we can get the thing down to the right frequency. We may or may not get lucky. Let's just see what we can do here. If I can get the slotted screwdriver into the slotted hole. Here we go. No, it came down a little bit, not enough. Let's do the other one. Yeah, that's my bottoming out the trimmer. So yeah, that's not really doing what I want. Still can't get it there. Let's try and set it around midpoint again on both of these trimmers, and we'll play with some more. I'll get 3.9 volts out of this thing. So I'm still playing around with capacitor values on this thing, and it's being fun. So I put 3 picofarads directly across the crystal itself to try and get the crystal down by quite a bit, because I put quite large values across the trimmers inside it, and it wasn't getting it there. And also it meant the trimmers themselves had a very little effect, because they were then being basically proportioned down by the capacitors across them. So I put that 3 picofarad across the actual crystal, and now I'm just playing with different values now across the trimmer to see if I can get this right. The trimmer is not bottomed out or anything, it's around centre point right now. It looks like the heater's just turned off, and that's why the frequency is now going back up again. So I want to see this stabilise, and then I can see if I can trim it in. If I can trim it in, then great. If not, then I might play with the capacitor a bit more that I've got across this trimmer. But that's looking pretty close. We'll see how it settles out, but that's looking pretty close. So this is looking very promising. As you can see, I've put the thing back into the housing, the actual OCXO housing, not the actual main unit, obviously. And I've just given a little bit of a trim, and it's looking like it's there. Now, obviously I won't know for sure once I've finished putting it back together and put it back into the actual unit itself, because that may affect the temperatures a little bit as well, and how it's sitting. It looks like we're there. It's in adjustment range, so it can be trimmed. Yeah, I think we're there. There may be some odd jumps as well, because I do have Wi-Fi in here and things like that. Could be affecting it as well slightly. Could pick up some interference. But generally, that's looking certainly good enough for what I need to do. I reckon I'll put it back in. Well, I'm going to solder this thing back in again now. So I'm just going to put a little fresh solder on these posts that these things solder onto, just to make it a little bit easier to get them going. Might need slightly more heat, but come on, a little bit low actually. That's better. So white wire goes in the top. Like that. Black wire in the middle. I'm really surprised these aren't twisted actually. And red in the bottom. Okay, fold it back in. There's a screw hole there somewhere. Can't hold on to anything. Where is it? There's one. Okay. Let's power this thing back up again, and we'll retest for the OCXO and the Rubidium Standard and see how we go with that now. So I've got to hook up to Rubidium now. Just waiting for the Rubidium to warm up and stabilise. It will take a little while. When that green light comes on, it'll be locked thereabouts. It's still got some small tuning steps it does, sort of fine tuning whilst it's running. It does take a little while to stabilise fully, but right now it's looking reasonable. You'll see this jumping up and down as Rubidium's tuning itself. It's quite normal. But once it's done, then we can wait for everything to warm up, and I can adjust it again, and hopefully then it'll be okay. We shall see. There you go. It's Rubidium tuning itself back up again. Green light's just come on. So as far as the Rubidium goes, it thinks it's locked. So that's looking pretty good. Everything still needs to warm up fully though. So I might actually put the cover on this as well and get this fully up to temperature. But I should be able to tune this in now with a bit of luck. Well, this is looking pretty promising. It's hovering around this number here now. It's still drifting downwards very, very slowly, but I think that's basically bang on now. I'm pretty happy with that number, 10 megahertz from the Rubidium there. Oh, drifted down a little bit. Oh no, we lost the zeros now. But I haven't adjusted this. I adjusted the OCXO on the bench and I had the thing out to my 1992 counter up there, and even that wasn't precise. It's about there, and then we dropped it in and it's looking really good. I think that's probably good enough to be happy with, really. I might leave it on for like an hour or so and then just tweak it a little bit if I need to, but I think that's probably good enough. Sometimes it's showing a 1, sometimes showing 9s. Might leave it there, we'll see what happens. Well, I'm happy with that. It's looking really good. I'm going to let it stabilise for an hour, maybe a bit longer. I'll leave it on for a while and see what ends up tweaking up to in the end. But it might even stay where it is now. It's looking really stable now. That's looking promising. So if you like that repair video, subscribe if you're not already subscribed. There's some more addendum to this. The original lever, one was missing, one was, well, basically fell off when I touched it. So luckily I did still have one lever. So I've modelled this up in CAD and I've printed new lever caps here. So new caps, very much like the original one. They're basically the same design. They're not 100% the same. They're very slightly longer, like half a millimetre longer, and the end isn't dead flat like the original one. It's just got like a slight concave on it, just because the modelling was a bit easier. I could have been a bit lazy, to be honest. But the rest of it is basically exactly the same. They push fit on and do a nice solid fit. So if you have one of these things or another unit which uses the same keycaps on these lever caps, these files will be on my Thingiverse page if you want them. So go help yourself. And that's what they look like close up. Same as the originals. Obviously I printed these in beige. You know, if you want to keep it looking the same, put it in black, you'll never even know. If you want to help me buy equipment to do videos about a bit like this, there's a Patreon support link over there. Click on that. You come on Patreon. You can donate just as little as a couple of dollars a month. That's all it could be. And that helps me to buy equipment to do videos about. And when you become a Patreon, you get the benefits of, when I do a repair like this, I'd include the service manual with it and things like that, and the Patreon information. I link the files in. If I've got firmware, I'll attach the firmware, that sort of thing, you know. Those are the sorts of things I do to give it perks to the Patreon. So if you've got something like this and you need help fixing it, and I've done a video about it, there's a good chance that it's on Patreon and the files you need are there. Happy with this? Other videos to watch down below too if you want to check those out. Catch you later.